Greetings. We will go through the exemplar problems in the class 11 physics motion in a straight line. Okay, before that, let me show you the important kinematic equations. Okay, one equation, final velocity equal to initial velocity plus acceleration into time. Okay, v equal to u plus at. And the other equation, distance or height, whatever you get, distance equal to initial height plus initial velocity into time plus half at square. Okay, this is acceleration, time, initial velocity, initial height. Final velocity square equal to initial velocity plus 2ax. X is the displacement. So this is the displacement. You can say initial velocity plus final velocity divided by 2 into d. Average velocity equal to v plus v0, initial velocity by 2. And from equation 2, if you say initial height is 0, then here if you substitute this initial height 0, then you will get this equation. Okay. For free fall, acceleration is minus 9.8 meter per second. This is a constant. Okay. So among the four graphs, there is only one graph for which the average velocity over the time interval can vanish for suitably chosen t. Which one is it? See, average velocity is displacement by time. So if you look at in these graphs, the time is not zero, time is keep on increasing. So when average velocity is 0, then displacement has to be 0, then only the average velocity can be 0. See here, if you see this, in the all the graph, in this graph we are starting here, displacement is a vector, so it is going here, so this is vector is in this direction, then I am again coming back, so the same position is coming to the same position again in this. So here in this area the displacement is 0. Okay, so when displacement is 0, this average velocity is 0. In this figure only it is there, but all the others, see, starting here going like this, we are not coming to the same point again. So here only in this curve we are starting here and we are coming to the same point. So this direction vector and this will cancel, so displacement will be 0. Lift is coming from the 8th floor and it is just about to reach the 4th floor. Taking ground floor is the origin. This is important. So okay, and positive direction upwards. So when you take ground floor origin, then only lift, you can say lift is coming downwards. Was all quantity, which one of the, so displacement is less than 0 because of lift is coming downwards. When displacement is less than 0, velocity also is less than 0. See, when the speed decreases, then the velocity decreases, the velocity and acceleration are in the opposite direction. Okay, so that means velocity, if speed decreases, velocity less than 0 means acceleration greater than 0, rate of change of velocity. Okay, in one dimensional motion, instantaneous speed v satisfies, okay, this. So Q3, question number 3. Okay, instantaneous velocity is to dx by dt. So v equal to dx by dt, dx equal to v dt. So for time t it is v0 t, and time on the negative scale is minus v0 t for the negative velocity, because velocity can vary from minus negative to plus negative and also positive, say vector. So that is why x can vary from minus v0 to t plus v0 t. Okay. A vehicle travels half the distance L with the speed is, and the other half distance with the speed, the average speed is. Okay, so first average speed. So first L by 2 with this velocity and the second L by 2 with the velocity 3.4. Okay, average speed equal to path length divided by time interval. Path length first half plus second half. So assume t1 t2 is the time. So this will be velocity t1. We can find the length. Length is L by 2 divided by velocity 1. So the L by 2 v1, L by 2 v2. Okay, so now we can take this L as a common here, then you will get this equation. Then finally we get 2 v1 v2 v1 plus v2. Okay, so 2 v1 v1 plus this is the answer, average speed. Arithmetic mean of the individual speed you have to do. The displacement of a particle is given with this equation, where x is in meters and t is in seconds. The distance covered by the particle in 4 seconds. See, first 4 seconds they are asking, not at the 4th second. First 4 seconds they are asking. Okay, that is important here, not at the 4th second only, first 4 seconds. So we will see how much it covers in various thing. 5. So this is the thing, we are differentiating that displacement equation. So 2 into t minus 2 power 1. Okay, at t equal to 0 we will get minus 4, t equal to 0. So the total is from 0 is minus 4 to plus 4, that is 8 meters. So that is why you have to understand, first 4 seconds they are asking, not at the 4th second. Okay, so 8 meter, minus 4 to plus 4, 8 meter. At a metro station, a girl walks up to the stationary escalator in time t1. If she remains stationary in the escalator, then escalator takes her to t2, time taken by running escalator. So you have to add both the velocities. From time you have to find the velocity, then you have to add 6. See, the velocity of the girl in time t1 she walks, that is the length of the escalator L. L divided by t1 will give the velocity of the girl when she walks in the stationary escalator, and the velocity of the escalator this. So when the escalator is also means she is also walking, then total divided by the combined velocities will give the time. Okay, so the combined velocity is this and the total length. So after that you will get t1 t2 t1 plus t2. Okay, this is the answer, time taken by air to when escalator is moving, she is also walking. The variation of quantity A with the quantity B plotted. Okay, so they are asking now, describe the motion of the particle in a straight line. Describes the motion of the particle in a straight line. So quantity B being present. Okay, they mostly in the graphs you have seen time x-axis. Okay, it can maybe time. Quantity A is velocity, motion is uniform. See, when motion is uniform, it is then mean velocity will be constant, so it will not vary. Uniform motion, this velocity will not vary. So this is not the answer. Quantity A is displacement. If more displacement can be like this, it keep on increasing. Uniform motion. Quantity A is velocity if motion is uniformly accelerated. Okay, uniform acceleration. Quantity, the velocity will vary like this. Okay. A graph of x versus time shown here. Choose the correct alternative from the below. The particle, okay, here it is released. Okay, displacement is 0 here. Okay, because it stays here only, so it is released at the rest. At B, the acceleration A is greater than 0. At B here, but at B, A, because this is a flat, so it can't, velocity is 0, so A can't be greater than 0. Okay, at C, velocity and acceleration vanish. Okay, goes up. Here also is like a flat, it vanishes. Average velocity for the motion between A and D is positive. A and D, average velocity, okay, it can't be positive, it's a negative, it is A and D. So A is here only it become negative, and it reaches the same position after that, then it will become negative. So this is not the answer. The speed at D exceeds, yes, the slope is here more than here. Okay. For one-dimensional motion described by x equal to t minus sin t, x of t is greater than all greater than v of t. See, if we have to find out the velocity and acceleration by differentiation, 3.9. Okay, we are differentiating, this will become 1, then it will become cos t. When you differentiate this again, then it will become sin t. Okay, cos the cosine and sine. Okay, sine varies from 1 to minus 1, cosine also varies from 1 to minus 1, but here 1 minus cos t is given, so 1 to minus 1 it will vary. When it is 1, then it will become 0, when it is minus 1, it is 0 to 2 here. Okay, 0 to 2 variation. Sin t is 1 to minus 1. Okay, zero to 2, v of t, here the velocity is 1 minus cos t, so it is greater than 0, but 0 is also is there, 0 to 2 it can vary. Okay, a of t, this is 1 to minus 1. Okay, here also 0 negative also is there. Here negative also possible, 1 to minus 1. V of t, this is correct. Okay, because 1 minus cos t, when cos is maximum 1, then it will be 0, and minus 1, then it will be 2. A spring with one end attached to a mass and the other is rigid support is stretched and released. Okay, you can find out from the net also. The magnitude of the acceleration when just released is maximum, the speed is maximum, and mass is at equilibrium position. Okay. A ball is bouncing elastically with the speed of 1 meter per second between the walls of a railway compartment of size 10 meter. Okay. In a direction perpendicular to the walls. The train is moving at a constant speed 10 meters per second, and that compartment size is 10 meter, parallel to the direction of the ball as seen from the ground. They are saying the direction of the motion of the ball changes in every 10 seconds. No, The speed of the ball changes every 10 seconds. Speed of the ball is 1 meter per second, and this is length is 10 meter. So every 10 seconds the speed will change. Okay, and average speed of the ball in any 20-second interval is fixed. Okay, up and down. Acceleration of the ball is same as from this train. Yes, when you are inside some moving object, then acceleration of you is same as that object. Okay. Okay, very short answer. Refer to the graphs. Okay, the first four graphs, and these things are the answers. Okay, for A has a point with a zero displacement for t is greater than 0, and B these things you can go through. An uniformly moving cricket ball is turned back by hitting it with a bat for a very short time interval. Show the variation of its acceleration with time. Take acceleration in the backward direction as positive. Okay. Okay, this is the graph, and in this place the here acceleration is 0, this is 10. Here when ball is hit at this point, suddenly acceleration is go up, then it's coming down again. Okay, this is the point where the ball hit the bat. Give the examples of one-dimensional motion where a particle is moving in the first acceleration, comes to rest periodically and moves forward. Okay, and this show the on spotting. This is the one we can differentiate it and see. Okay. Give the example of motion where x is greater than 0, v is less than 0, and a is at a particular instance. 3.15. Okay, you can write the equation like this. Chosen for positive constants. An object is falling through a fluid is observed to have acceleration given by this equation. G is the gravitational acceleration, B is the constant. After a long time of release, observed to fall with a constant speed. What must be the value of the constant speed? When there is a constant speed, this is acceleration is 0. Okay, 3.16. 3.16 you can okay, so acceleration is 0 and this is the answer. Okay, v equal to this. The a ball is dropped and its displacement versus the time graph. Okay, this is the one. Okay, v is okay, is given plot the qualitative velocity versus time graph, not only acceleration 3.17. So this is how velocity varies, positive 0 negative, positive 0 negative, and this is the acceleration. The particle executes the motion described by this equation. And the particle starts at 3.18. Okay, here this is what they given. You can go through the details. A bird is tossed flying between the two cars, moving towards each other. Okay, the cars moving towards each other. That is important. One car is speed, the other car speed. The bird start moving from the first car moving towards the other car with the speed of 36 kilometers per hour, and two cars were separated by 36 kilometer. What is the total distance covered by the film? Okay, moving cars towards each other, so we have to add the velocities together. Answer: the relative speed of the cars, we have to add the velocities of the both the cars. Time required to meet is the distance divided by the velocity, so this is the time. Thus the distance covered by the bird is 36 kilometer per hour into this much kilometer. A man runs across the roof of the tall building and jumps horizontally in the hope of landing on the roof of the next building, which is of the lower height than the first. If his speed is 9 meter per second, the horizontal distance is 10 meter and the height is between the first building and the second building 9 meter. Will he able to land on the next building? Okay, so this is formula is related with the reaction time. Page 13. This is the reaction time. They are using this formula. So 20. So they are given the details how it happens. Okay, we are using this is the distance formula: initial velocity minus acceleration time square. So E will land. A ball is dropped from the building of height 45 meters. Simultaneously, another ball is calculate the relative speed of the ball as a function of time. Okay, so you have to use those kinematic equations. 21. Okay, so the initial velocity is 0, v1 is minus 10d, and then next time is initial velocity is 40, so v1 minus v2 equal to minus 10t minus 40 plus 10d. Minus will become plus here, so it will cancel off. v1 minus v2 is minus 40, v2 minus v1 is plus 40. So the modulus, if you take it, will be 40 meters per second. So it will be 40 meter per second. The velocity displacement graph of particle is shown here. Write the relation between the velocity and displacement. Append the relation between 22. So they have given this equation, you can go through it. It is common observation rain clouds can be seen about a kilometer above the ground. So if the raindrops fall from such a length freely, such a height freely under the gravity, what will be the speed? Also calculate the kilometer per hour. In kilometers per hour they are asking instead of meter per second. Typical rain, in these things the answer is given. Okay, so they are using this formula. This is from one of the kinematic equation. v square equal to initial velocity square plus 2ax. So v equal to square root initial velocity 0 means this equation will become like this, and you can go through this meter per second to kilometer per hour. We are converting 1 kilometer 1000 meters. 3600 second is 1 hour. Okay. A motor car is moving at this also you can go through the answer. 24. Okay. That is given. Monkey, this answer is given. A man is standing on the roof of the tower 100 meter high. He throws two balls, one at t equal to 0 and the other after some time. The latter ball is thrown at the velocity half of the first ball. Okay, we are asking the calculate the velocity for which balls, velocity of both the balls thrown at the exact time interval between them. 26. We have to use these kinematic equations. Okay, initial thing, then we have to find out the difference between the display. So velocity 10 meters per second. Initially first thrown is 20 meter per second, the second is 10 meter per second. First ball displacement 20 meters, second ball, you can use these equations. Okay, so you see these equations how I use. Then after that is t1 2 second, t1 minus t2 is 1 second, t2 is 1 second. Okay, so here the two formula, distance, initial velocity in time plus half at square we are using, and also this formula. Okay, try to solve the problem yourself. Okay, then only you will be able to understand the various formulas.